hello, everyone. Thanks very much for having me here today. I am going to get my screen going here, and we will get this started here. All right. Thanks, everybody. I'm Ryan Fox, and my first time in Lagos on stage, so thank you very much for having me here during Startup Week. We're going to cover the Blockchain Development Workshop here for the next half hour. So hello and welcome. That's me, a little bit younger there. I am a developer advocate at the Alaran Foundation. I am based in Boston in the US, and I am thrilled to be with you. If you want to follow along with me, I am on Twitter. I am at Ryan R. Fox. So if you find this session interesting, be sure to connect with me on Twitter. All right, so what are we planning to do today? All right, what we are going to do is I'm going to give you a little bit of an introduction to decentralized application development and how that compares to traditional application development. And then we are going to move into installing a development environment for this. And then I will have you build. Yes, in Web3, we spell things a little bit oddly. Yes, so we are going to build a Hello World application. And then finally, we are going to interact with that application that you have all built. You'll actually be able to do all of this stuff, the play at home game, if you like, right there in the audience. If you have your laptop ready, we'll show you how to do it. We're going to use AlgoKit and dApp to do all this. All right, so how about this? Nobody likes to look at presentations for very long. People like to do code. People like to see what's going to happen. So let's just skip to the end and let me just show you exactly what this is going to look like. So in the end, this is what you will have built. All right, so we are going to use this application here, dApp. It's a web browser application. And in here, it is going to be able to display the methods that you will create here. So a nice user interface here. We have our hello world method here, and we are going to be able to execute that. We will notice that this method name, hello, has a series of arguments, and in fact, just one argument here. It is named name, and it is of type string. So we need to put something in here. So how about if we put in, well, where are we? We're at the Lagos Startup Week. So we are going to say hello there, and we are simply going to execute this here. And we're going to watch over here that this has now taken this data, sent it to the blockchain, executed it in this transaction successfully, and then down here at the bottom, we will see the return value. So we see that it says, hello, Lagos Startup Week. This is the string value that we sent in. Our smart contract code included this portion of the string. So every time that we say something different and execute this code, it will return the value for whatever we pass in. All right, super basic, of course, but that's right? Super basic. So let's move on with the presentation, and we already know what's coming up. So let's get into it. Let's start with a little bit of an introduction to decentralized application development. Let's start from where you know, right? Like this is where all developers typically start, right here in an integrated development environment, the IDE, VS Code in this case. This is exactly the way that we do it here in Algorand as well. So we've got a great tool set that we will use integrating in with VS Code. Coming from a place where you are, right? Traditional application development, because I'm going to make the assumption that the vast majority of you are startup entrepreneurs, founders, developers, and many of you then have seen this three-tiered architecture model, where we have a presentation layer, a storage layer, and a compute layer in between. And we are able to interface between these three different layers to provide a complete application environment. We typically see that represented as a web browser, either that on your desktop or on your mobile device, proprietary database on the back end with a web server in between. And you'll make calls from your web browser to the web server. The data will come from that database and will be presented back to the user on the browser side. So that's what traditional application application architecture looks like. And I want to contrast that to what it looks like for decentralized application architecture. So we're going to use that same three-tiered model and start with that. And then let's see what we first take away. So we actually take away the web browser, I'm sorry, we take away the web server and the database concepts within the compute and storage portions, and we replace those with a blockchain virtual machine and smart contracts. All right, now we'll get into defining what smart contracts are briefly, but think of the blockchain virtual machine as this compute environment where, and then the smart contracts are the place where we're going to store the data. And we will then have the interface between our users on the presentation side coming into this blockchain virtual machine. And we need to introduce one additional piece here for decentralized application architecture, and that's the wallet. So we're still going to have our browser, but we are going to then add along with it the concept of a wallet. Now, a wallet has or holds your digital identities. It holds the ability, what it's used for is to sign transactions that will then be sent to the blockchain virtual machine, which will fire off the logic within the smart contract. And if that executes successfully, then we will see the representation of those changes in the blockchain and represented on the user display on the presentation side. So decentralized application architecture is fairly similar if we use a three-tier model comparison here, just making sure that we are swapping out the centralized web server and centralized database with the decentralized blockchain virtual machine and the immutable smart contracts, and then adding in that wallet. So let's take a look here. Oh yes, we'll have a cool animation of how this interaction works in just a moment. So smart contracts. Importantly, smart contracts are code and they are comprised of three components. So the first one is business logic, all right? So your code, right? You are going to have your code do something and you are going to follow various paths, evaluating the parameters that are passed into your methods and have your code do something, right? So business logic, that's what the traditional software developers are all writing. Same thing here within code for smart contracts. Secondly, we're going to have data storage. So the smart contract itself, as I noted, acts as the database. We are going to update and store various data elements, and that will allow our users to update based on the business logic that executes what is the state of this particular smart contract. And the third component is then going to be an interface. So the smart contract itself will provide an API or an ABI, application binary interface, which will allow the smart contract itself to inform end users or user interfaces what are the available methods for this particular smart contract, and then what are the types that are required to make those method calls. So the interface is there and published, and then the client end user can consume that and be able to know how to interact with this particular smart contract. So those are the three pieces of what a smart contract looks like. So let's take a look now at the interactions of a dApp, of a decentralized application. All right, so what is going to happen here is we are going to use our compute environment that we are familiar with. We'll start on the we'll start on the left-hand side there on the presentation layer, and what will happen is that the client will look at the ABI, that application binary interface, to get an understanding of what does the smart contract contain, and build a user interface for the user to make application calls. The user will use their wallet to sign transactions that will be sent to the blockchain virtual machine. The business logic will be evaluated, and based on the consensus and the execution path of that particular smart contract, the state, the data elements within the storage tier will be updated on the smart contract, and then ultimately back to the presentation side where those updates can be rendered for the end user to see. All of the data and those updates are immutable, meaning that they cannot be changed once they are written to the blockchain, and that's the primary difference between traditional software architecture and decentralized infrastructure, where you have a decentralized compute environment for dApps, and everybody can see the same state of the world and do not have the ability for some third party to come in and manipulate that database behind the scenes. Hope you will build the future using the dApp designs here. So let's take a look now at actually building something. So we're gonna get into that. But before we do that, we need to install some software here. We are going to use AlgoKit, which is the software development interface for the Alaran blockchain. All right, so what is AlgoKit? All right, AlgoKit is the window into Web3. All right, it has three components as well. First of all, AlgoKit is a tool chain. So when you download AlgoKit, you are downloading all of the components necessary to set up your development environment, and all of the libraries will be installed here within VS Code for you. Nice and easy. If you want to use a different IDE, you are certainly free to do that. The second component is, oops, wrong direction here. AlgoKit is templates and a tool chain. So the templates we have built in here, we're going to do one of those today, but we have many for various primitives within the blockchain space, auction, crowdfunding. We're going to do the Hello World one today here. The third component for AlgoKit is templates, toolchain, and Web3 infrastructure. And what I mean by that are all of the components that we saw within those three tiers. So blockchain networks, the wallet, as well as APIs. And then lastly, an explorer so that we can see visually what is going on the blockchain within those smart contracts and have a nice user interface to do some testing. So AlgoKit is what you need to get started writing smart contracts for Alaran. All right, what are the prerequisites? Here you are. As Python developers, I think that many of you will already have the first one being Docker. So we use this virtualized environment to make it much easier to install and manage all of the bits that we have for you in AlgoKit. So Docker 4.8 is required, along with Python 3.10 or higher. And then lastly will be PipX. PipX is a modern package manager, and it is very easy to install just by going pip install pipx, and then you will be ready to go. And then lastly, you will be ready to install the AlgoKit itself, and that is the simple command of pipx install AlgoKit. And you'll get a response like this, so that AlgoKit will be installed and it's running globally. So, outstanding. Next, we are ready to build. All right, so yes, actually, let's just show this here. Well, we'll go into this. All right, we are going to cover what are once you have it installed. We are going to tell you what the three main build processes are. So there are three commands. The first one is AlgoKit init. AlgoKit init is going to bring up the template wizard so that you can select which template you would like to build from. And then it is going to bootstrap your toolchain. Ultimately, you will compile that source code and then get it deployed to the blockchain, which is running locally. So you need to issue the second command, which is AlgoKit localnet start. Does exactly that. It starts a local network on your workstation. That's running within Docker, so everything is self-contained there. So now that we have the infrastructure running, you can do our third command, which is AlgoKit localnet explore, which is going to bring up that web browser interface, the dApp flow, and we will be able to see then into the blockchain and be able to interface with the smart contracts that you have deployed. All right. Oh, yes. There are a couple of other components that go with that, meaning that you have to connect your wallet. deploy your smart contract, and then we will interface with it using the Beaker Studio. So we will go through that. Let's stop this part of the presentation and get into the code, because let's face it, who came to see code? Glad you guys are here. All right. First thing that we need to do is install AlgoKit, and I have already done that, but as a reminder, it was just hitbox install AlgoKit. All right? And it will go ahead and do that for you. No problem. I've already done it, so don't worry. Next thing that we are going to do is our first of 3 commands. So we are going to do AlgoKit init. All right. And here it is going to bring up a wizard, and it's going to ask you which of the templates would you like to do. We are going to just choose, we can use the up-down arrow to do this. We're just going to use the Beaker starter template today. So that's the first one. I just hit enter, and then it's going to ask me to name this one. So I am just going to say hello world. And then it is going to begin asking me a series of questions. I'm just going to take all of the defaults here. So I'm just hitting enter, 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 and I am taking all of the defaults. If you are interested in all those things that are being installed for you, you are more than welcome to take a look at that. As you can see here, it is downloading and installing all of the various components that are necessary to work with this template. So we are now going to get into it. It automatically brought up VS Code here for me and has initialized this environment for me. Brought up the README file. We're going to go through what it is, but I want to quickly get us into the code itself. So we are going to look for app.py, and we are going to kind of just minimize this and maybe make this a little bit bigger so that we can get it all up there on screen for you at one time. I think that's about the right size for it. All right, and then we are going to use the run and debug piece already built into this by default. We've got a couple of different options here for you to build or build and deploy. We are going to use the default to build and deploy this particular contract. And when we do so, we just hit run. It executes the contract here. So this is executing against the locally running the AlgoKit localnet. And in the end, it tells us that it says hello Beaker. So by default, this smart contract has, or this test script has put in the string value for Beaker, and we will see how we can change that. The other important thing that this has done is it has now added or created some artifacts, meaning that it has created these various files for us to take a look at. The important one here being the application.json file. Now, this is a representation of the smart contract code. In fact, it has the smart contract code here in base 64, which really no human can read. But more importantly, it has a listing of the contract. Notice that it is named Hello World, and that it has all of the methods that are included for this particular smart contract. And in this case, the method, there's only one, is named hello. It has arguments of type string, named name, and it will return a string value. All right, so we've already seen this, but what we're looking at here, this is the ABI. This is the application binary interface. And what that means, of course, is that it is both human readable. We can kind of reason about what this is, and also machine readable. So a web designer can take this and ingest it in and have automatically rendered a user interface that would be able to ask for a string value, have a submit button, and be able then to expect that it would return a string value as well, so that it could then display that to our users. So now that we have this application specification, we can then import it into our dApp flow. So what I am going to do here is I'm going to issue our second command, which is algokit localnet start. And this is going to start all of our infrastructure so that we can ultimately deploy that smart contract to this infrastructure. As you can see here, it spins up the Docker containers. They're running, they're healthy. If we wanted to get a status on them, we could do that. We could see that we have these various components running and their versions. So our infrastructure is all set up, ready to go. We will now issue our third and final command, which will be algokit localnet explore. All right, now this will prompt a web browser to pop up for us. And here it will connect to all of the infrastructure that's running locally on my machine here. All right, so what we need to do then is connect our dev wallet. All right, so remember, like in our model, we had to add this concept of a wallet. All right, so we're all familiar with using a web interface, and typically we sign in to some cloud provider. You know, we'll use Google IDs or Microsoft ID or something similar, and that's going to the centralized party. Here we are going to keep our identity here within our wallet. So we will click this button here for dev wallets, and by default you will not have one, so I'm just going to delete this one. So when you initially connect, you will have it empty, and you can create a wallet for you, which now generates that locally. And in fact, since we're on this test environment, is sending 100 units of algo to this address. So this identity on this local blockchain now has some funds in it so that it can actually do something with those. All right, so we have created this wallet, and then we need to click the button here to connect it. All right, and when we do that, we will select from our wallets, and we are going to choose the dev wallet. And we will then notice that the interface updates with this address that starts 2 November Tango, which matches this one here. All right, so we have our wallet connected. Now we can come up here to our dashboard, and we can take a look at all of the various components that dApp Flow has. The one that we are interested in working with is going to be Beaker Studio, which is going to allow us to import our application. All right, so don't have any applications installed yet, so let's come on over here and import an application, and we are going to do this by uploading a file, and the file is the one that we looked at earlier, which was in the artifacts folder, and it's called application.json. Now, this specification file, right, is able to be read by the website here, by dApp Flow, and is able then to know about its logic program here, its approval program, as well as all of the methods that it has available. So it has that there. Now what we can do is come up here to the top, and we can click the button to create this application. This is going to then take the program code and install it into the blockchain using the signing wallet here that we have connected to. All right, so when we do this, it's going to ask us which application file. We've already selected it, so hello world is going to get put there, and we can simply hit create. And voila, the transaction is successful straight away. And we now see that our application ID has been updated here. So the application that was created is identified as pen10. And now we can actually come down here and execute whatever you would want. So if you put in any value, it will execute it and return that here. So hello, any value. All right. Again, hello world stuff, not terribly interesting, but this is proving it out. So let's go take a look at the code now that this created, or what I should say, the code that created this. So we're going to come back here to our app.py file, and we are going to start at the top and work our way through it. All right, so we need a couple of imports here. A couple of the libraries that we use within the Alaran developer ecosystem are called Beaker and PyTeal. PyTeal is a Python-based language for writing smart contracts for the Alaran virtual machine, and Beaker is a nice framework that helps us simplify much of the code writing for that. And then we have some local utilities to help us build. So in order to create this application, all we have to do is create an instance of the application class and give it a name. So here, we've just given it Hello World. And then we are going to then define some external methods for our application. In this case, we've already seen this, right? We are going to define the hello method, and we know that we have naming it, naming our first variable name, and of type abi.string. So this is not exactly Python, but this is PyTeal that you're looking at here. So ABI is a class within the Python library, and it has the typing of string, and yes, it is string, but it has been modified so that it works specifically for the blockchain. Then we have this little star separator. This is a Python indicator to say the values to the left of the star are the values that I'm passing in, and the values to the right are the values that are going to be output, or the return values. So here we have one return value called output. It is also of type string. So this defined method called hello is going to be rendered as an expression in PyTeal, and it is simply going to return. And what is it going to return? Well, let's start in the center. All right, so we see here that we have this string, right? We know this is hello, comma, space, all right? And those are of type bytes, and we are going to then concatenate those bytes along with our value name that was passed in, and we are going to then use the method to get that value and then concatenate it together, and then ultimately we are going to set the concatenation of those two string values to the value output, which is our return value here, and therefore this method, when called, as we have seen, will then return those values every single time. There's another method defined here to delete, and this is adding in the fact that only the person who creates this, so the creator address, be able to delete this application. So there is some quick insights into how this code looks. Now, we've already seen that work, but let's think if we wanted to do something a little bit more exciting. We could copy this method here, and let's modify it. Let's try to make a calculator. Let's try to do add. All right, so instead of string values for this, we are going to use type uint. All right, so we are going to use some unsigned integer values here, and instead of name, we're just going to call this A, and we should probably also have a B value, right? So that we would pass in both A and B of the same type, and what are we going to output? Instead of a string value, we are going to also output a uint value here. Now, instead of setting this value to this string, let's try to do some math. So let's try to do A plus B, all right? So this means that the value A is going to get passed in and get added to B, right? Let's see if that works. All right? So we'll build it, and we will wait for our piece to come back, and it'll say, oh, unsupported operators. Oh, all right. So we can't just do straight up Python here. We have to do we have to do this for PyTeal. So what we need to do then is And then we need to say that we are going to add, oops, and add these together here like this. All right. And give me just a quick sec. Why I take a look at this and why I'm getting a little bit of error on this. All right, we are going to move along here to the next section here. Just give me a moment here. Live demos are always exciting. And we are going to remind us where we have been here. So we have done all of this. We have gone through and done our interacting piece here. And I just want to remind you that if you found this interesting, then you are certainly invited to come along and join us for these other sessions that we have available. So on our developer portal, we have developer.algorand.org, where we have lots of great content there for you to learn how to develop smart contracts and extend what you've learned today. Then we also have the Algorand Developer Bootcamps that are kicking off on Monday. If you are interested in joining us, those will be happening live each day next week from 13 UTC. They're free to join. You can do that on our Discord server. So discord.gg/Algorand is where those events will be taking place. And you can also learn all of this content on YouTube. So we have our AlgoDevs YouTube channel, and we would love it if you would join us there. Then, reminder, this is who I am, developer advocate at the Alaran Foundation. You can follow me along on Twitter if you found this information was helpful. So thank you all very much for having me today.